Hey learners, welcome to Mac. So learners, we're gonna learn time complexity and space complexity in this video. And how to calculate them. So first of all, what is the time complexity? Time complexity is just a way of expressing the amount of time an algorithm takes to run. So with which is calculated with the help of a function in the function with the help of an input. We can just see that, and it is just you can also say that it is a measure of how what is the runtime of an algorithm, and generally it is denoted in with the bigonotation, which is just the upper bound for any growth rate for an algorithm's runtime. So there are some prerequisites which you should know, such as intervals. You can see over here in the square bracket, which is written of a and b, which means that it will all include all the numbers between a and b, and also the number a and b. So you can see over written, I am just written this inclusive, which means a and b will be included, such as for example, if there is a 5 and 1 written and this is a square bracket, it means that all the numbers between from 5 to 11 will be included. And this for this round braces means if it is written a and b, so this means that it is exclusive, so a and b will not be included in this this structure. So if for instance 5 and 11 with this round braces, so all the numbers will come between 5 and 11, and these two numbers 5 and 11 will not be included. So to get the total of numbers for this with the inclusive a and b, so we can just get the total number of numbers in it by just subtracting a from b, and just after that just adding 1 to it. So now just see basic of arithmetic progression, which is such as arithmetic progression, which is what which starts from such as a, and it is, and with every number means in the series it will just add one number d means d with a interval, and after that it will add a plus 2d, a plus 3d, just like it goes on to a plus n minus 1 into d. So to get the sum for this arithmetic progression, we can get this by simply just getting the n by 2 multiplied into 2 into a plus n minus 1 into d. So with the help of this we can also calculate the sum of first n natural numbers, which can be which is derived with this formula, and you can see over here it is n into n minus 1, then divided it by 2. So now just see the geometric progression. If for a geometric progression is what a number which starts from a, and it goes on with the a will be multiplied with r, and then a will be multiplied with r square, and then a will be multiplied with r cube, and this goes on to for n terms a will be such means a into will be multiplied by r into the power n minus 1. Sorry, a will be multiplied with r to the power n minus 1. So you can see that for this in this series that this number is a, and when it is multiplied by 2 means this is this r, and with every interval which you can see 5 and 10, and this it is 20, so a and r square. So 5 into r 2 square means 5 into 4, which is 20, after that 40. So how to get the sum of this? So sum you can just get that by multiplying a with r to the power n minus 1, and just dividing this whole by r minus 1, which is with provided that r should not be 1. Okay, so now proceed further. There are some basics of logs. If you just take an example, that's 2 power 3 is equals to 8. If you want to get this 3, means the power of this expression, so just for instance you can take it that 2 as a, 3 the power as b, and the result 8 as c. So you can just write this like this: 8 to the power b is equals to c, and you can also just simply like that c, then b root of c is equals to a. You can like that this. So then cube root of 8 is equals to 2. So if you want to get this power, so you can just get with the help of log function. Log, you can just do this like log 8 to the base 2, this a 2, and just you can get the power. So in this expression you can just write it like this: log c to the base a, and then you can just get the power. So now proceeding further, as I have told you that time complexity is just expressed in bigonotation. So there are some rules for it. So such as the number of iteration are based on the input size. Okay, then we have to omit all the lower terms, and also omit all constant coefficients. So there is an example over here. So if you go with this these rules, then first you have to omit all the lower terms. So in this example you can see that there is the expression is what, 2n to the power 3 plus 3n to the power 2 plus 5. So first we have to omit all lower terms. So just remove all this lower terms. All these lower terms are removed, and then we have to remove all the constant coefficients. So this is the constant coefficient for this. So this also remove this, and then what will be the answer? Answer will now be that this time complexity for this expression will be order of n to the power 3, which comes from here. So now there's one other expression you can see over here. So this is 3n to the power 4 plus 2 root n plus log n plus 90. So first we have to omit all lower terms. So just remove all these lower terms, and then just we have to omit all the constant coefficients. So this is the constant coefficient, so just remove it, and what is this remaining will be the answer. So answer for this will be time complexity will be order of n to the power 4, which we are getting from here. So there are some expression order which we can just which you can know that log n is less than root n, and root n will be less than n will be less than n log n. It will be n log n will be less than n root n, and root n will be less than n square, and square will be less than n cube, and just we go further, n cube and just like this it will be less than to the power n, and it will n to the power n will be less than factorial n, and factorial n will be less than n to the power n. So now with some example, let's try to understand and calculate the time complexity. So now just see in this loop, in this method, this is a pseudo cone where this is a function in this loop is running. So how many times iterations are running? It is running from 1, and it will be running to the n. So you can see it is the 1 and n is included. So it is written over like this in this expression interval, and so within this there will be how many iteration for this? For this will be iteration will be n minus 1 plus 1. So it will be n only. So there is n number of iteration in this equation in this method. So what is the time complexity for this? Time complexity will be order of n for this. Okay, so this was a simple example. Now let's proceed further. Yeah. Okay, now with in this example, you can see over here that this is a function. There's a two loops in this function. So the first loop is running from 1 to n. So it is running for n times. This loop is running for n times, and then this loop, it is running from 1 to m. So this loop is running for m times. So for this loop there is will be the n iteration, and for this loop there will be m iteration. And since this loop is not inside this loop, it is outside, and this both loops are both independent. So we can so this number of iteration will be added in this, and what will be the number of iteration? And the number of iteration will be n plus m. So so number of iteration will be n plus m. So what will the time complexity for this? So time complexity will be n plus m. Okay. Now let's proceed further. Let's see another example. So this is a simple loop which is starting from 0 and it is going to 100. So you can see it is starting from 0 and going to 100. So what will be there will be 101 iteration. So because 100 minus 0 plus 1 will be 101 only. So the number of iteration for this will be 101, and the time complexity can be just, you can say that order of 101. But in when this means when there is a constant, so we just write the time complexity as order of 1. Whenever there will be a constant written over here in the order bigonotation, then we will just replace it with order of 1. Okay, so this now just proceed further with some other example. Now just try focus on this problem. Just pay attention. Okay, so just see on this loop that it is running, it is starting from I is equals to 1. In the condition, it is just checking that I multiplied by I, it is less than equals to n, and then I plus plus, and we are performing some task over here. So the how many times this loop is running? So just try to understand with this table which I have made over here. This first it is I, then it is I into I, means multiplied by I, and for instance I am just taking n as 25. Okay, so when I will be 1, I multiplied by I will be 1. So this loop runs for this time because it is less than equals to n. For 2 it will be means I into I will be 4, so loop will run. For 3 also it will be I into I will be 9, so this will run. For 4 also this will run. For 5 also the I into I will be 25, and it is less than equals to 25, so it will run. When the I will be 6, I into I will be 36, so this time it is more than the n, so it will not run. So you can see over here how many times the loop is running: 1, 2, 3, 4, 5. So when there is an n is equals to 25, it is running for 5 times. So you can see over here just this means it is running the square root of n. So with this expression also you can understand I into I is less than equals to n. So I will be what? Less than equals to root n. So how many times the iteration will go on? Iteration will be run on for root n times. So what will be the time complexity for this expression? This will be order of square root of n. Okay, Okay, now just proceed further with some other example. Okay, now yes, in this example you can see that I'm just initiating I with n, and in the while loop I'm just saying over here that I is greater than 1 or not. And in this under this while loop I am just dividing I by 2 and just assigning it to the I only. So now just try to understand with some with the table which is right over here. So for better understanding, I am just writing this I denoting this I as IA, and denoting this I under this loop as IB. IB. Okay. So when I is equals to n, it will just enter and will be greater than 1. So number of iteration will be 1. It is just entering it into the loop. And IB, where it is here, IB will be what? N by 2. So when control will come over here, n will be means this time I will be n by 2, and then you can also write this by 2 by 2 as 2 to the power of 1. So what is the number of iterations? It is will be going for the second time. So two iteration number of iterations will be 2, and then IB here will be just divided by 2. It will become n by 4. So if when IA will be n by 4 over here means, so 4 can also be written as 2 to the power 2. So the iteration will be now 3, and then n will become n by 8. So just if you go just proceed further, you can just assume that it will run for k iteration. After that this I will become 1 when dividing by n by just 2 to power k minus 1 times, as for as you can see for 2 this was 2 to the power of 1, for 3 it was 2 to the power 2. So when will be there will be k iteration, so n will be divided by 2 to the power k minus 1, and it will result in 1. So after that the loop will end. So so how many times the loop runs? The loop will run for k times, so we have to get the value of k. So now you can see, for our inconvenience, just we are writing this n by divided by divided by 2 to the power k, which will be here k minus 1. But for our convenience, just for a bigger loop, we can just write it as 2 to the power k, and it is equals to 1. So n will be equals to what? 2 to the power k. Just take this 2 to the power k and just put it over here. So we have to get this k value, because the iteration is how many iteration are there? K is the number of iteration. So we can just get it by how? With the log function we can get it. So here we can just get the k, that's log of n, and with a base of 2. Okay. So now in this problem, you can see the loop is running for what? How many times? Log of n to the base 2 times. So time complexity for this problem will be order of log of n to the base 2. Okay. So now just move to the another problem. So in this problem you can say there is a loop and for loop, and inside this loop there is also a for loop which is running for n times. So outer loop you can see it is running for n times, and the inner loop is also running for n time. Okay. So means outer loop will run for how many times? Outer loop will run for n times, and the inner loop is will also run for n times. But you can see for every loop the inner loop is running for n times. For if there is a loop run for 1 time, the inner loop will run for n times. But the outer loop is running for n times. So The inner loop will run for how many times? Then n into n in times. So how many times the overall the iteration will go on? So overall the iteration will go on for n into n times. So what will be the time complexity for this problem? Time complexity for this problem will be n into n, which we can write as order of n square. Okay. Yes. So now let's see what is a space complexity. So space complexity just refers to the amount of memory required by an algorithm to solve a computational problem, which will be as a function of the input size. So it will just measure the maximum amount of memory space which will be used by any algorithm during its execution. So space complexity is also expressed in terms of big O notation, just like time complexity as well. It will be having just means the same set of rules which was mentioned in the big O notation and for the time complexity. So just now let's move on to the problems, set of problems for this. So in this problem you can see there is a function which is just taking for first it is declared int a is equals to n, int b is equals to a plus n, and there is a long c which will do into y plus a, and it will returning z. So in the for an integer variable, the memory will be allocated will be 4 bytes. There is again integer variable. For this also memory allocated will be 4 bytes. And when there is a long variable, the memory allocated will be 8 bytes. So how many total number of memory allocated for this is 4 plus 4 plus 8, which will be total is 16 byte. So order for this will be what? Order of 16, which is a constant. So so as I have discussed earlier also, whenever there will be a constant, so we will just replace with order of n, order of 1, and we'll just express it at like this only. So we'll just remove this constant value. So now let's see some other example. So in this problem you can see this simple as there is an int, integer variable, long variable, and then there is an array which is taking as an means will be the size will be of n only, which is the given in the input. So the size of for this as for integer you can see 4 bytes will be there for integer 4 byte, and for long or 8 bytes will be there. But for this array this is based on the value of n. So that so the space for allocated for this will be 4 into n. So n is the input which is given over here. So the what will be the space complexity for this? For this will be space complexity will be order of all will be this add will to 16, and then it and then 4 in n. So as an array is a dynamic is a dynamic data structure which can contain a any size. So so it is generated, then it is expressed in the order of n only. So with this not only an array, the other data structures is also there, such as list is there, trees, and other thing was also there, which is expressed in the terms of n only, which it depends on the input size. So when it depends on the input size, it means when the size of the space is not fixed, so we will just write it in this n only, and just following the set of instructions for the bigonotation. Just that remove all the lower terms, so 16 will be removed, and also the constant coefficient should be removed, so this 4 will be removed, and finally the space complexity for this will be order of n. Okay, now just proceed to another problem. So in this problem you can see it is just as the integer long, and there is an array, dynamic array with the with which contains size of which n into n. So the memory allocated for this will be what, 4 into n into n. So how this when just expressed in space complexity, what will be there? First added all these will be 16 plus 4, n into n will be n square. So first we'll just remove all lower terms, so 16 will be removed, then remove all the coefficients, just 4 will be removed. Finally what will be the result? So result will be the space complexity for this will be order of n square. N is the input which is given over here. So learners, this is it from this video. So if you like this video, just hit the like button and do subscribe to our channel. We will be coming with more videos on data structures very soon. So yeah, that's it.